Hello young ladies and gents, welcome to my show Breaking Science. I am Hazel Hills and today we have two special guests with us today. Two physicists made separate groundbreaking strides into how an atom was structured. The first guest created the atomic model for the hydrogen atom, and give it up for Niels Bohr.
Well, ladies and gentlemen, so glad to be here.
Yeah, thank you. So how are you today?
I'm good.
We're gonna talk about your model. So I heard that you had a theory pertaining to the orbits around an electron. Please tell us more.
Okay. A model. In my model, electrons have energy levels. Energy levels are fixed energies that an electron has. Now, it can electrons can fluctuate energy levels by losing or gaining a certain amount of energy. That certain amount of energy is called a quantum.
Now, there was a physicist before you, Ernest Rutherford, right? How did his ideas, influence how your ideas and model came to be?
Okay, well, I met Mr. Rutherford back in 1912, and that is when I first saw his model. It was a great model. It's what my model is based on, but I had one problem with it. The thing was, to the basic rules of physics, his model would cause the electrons to lose and gain too much energy and would force it to collapse on itself. So I used quantum theory to figure out how it would stabilize the atom.
Well, Mr. Bohr, that seems like all the time we have. Thank you for your time, I mean. And when we come back, we'll have a second guest and find out who after this. Welcome back. We have a special guest with us today. He revolutionized the atomic model. Give it up for the Erwin Schrodinger.
Thank you for having me, Hazel.
So, how are you today?
I'm doing good. How are you?
So we're gonna talk about your model. You know that. So, who are your inspirations?
Well, I was heavily influenced by Niels Bohr and his model. He created it back in 1913 when I was still a young lad of 26 years old. His model and quantum theory were my main inspiration for my new and improved model and my equation.
Could you please tell the millions of Austrians about your model?
Gladly. To keep it short, my model is based on quantum theory, which states that matter is associated with waves. My model uses mathematical equations to predict where electrons are more likely to dwell. Now, my model is depicted as a nucleus encompassed by an electron cloud. The denser an area of the cloud, the more likely there will be electrons present.
I am sure that the people of Austria don't know what this so-called cloud is, so please, enlighten us.
Okay. Well, as I said before, it's an electron cloud. It's made of electrons. In my model, the probability of finding an electron within a certain volume of space surrounding the nucleus can be represented by a fuzzy cloud-like region. That's why it's called a cloud.
What is Schrodinger's equation?
Well, my equation is...
Care to explain this complicated equation?
Of course. There are four quantum numbers involved in the wave equation. So the four quantum numbers would be the principal quantum number, which is N, orbital angular momentum quantum number, L, the magnetic quantum number, M, and the electric spin quantum number, which is M2. These quantum numbers describe all of my solutions to my equation.
Oh, what are the functions of these quantum numbers?
The principal quantum number, N, describes the approximate distance of an electron to the nucleus. L determines the general shape of an orbital. M determines the number of orbitals and their orientation within a subshell. And M2 designates the direction of the electron spin.
That's the bee's knees, man.
Okay.
Want to inform us about these atomic orbitals we've been hearing about?
Okay. atomic orbitals describe the probability of finding an electron at various locations around the nucleus. There are four principal energy levels. There's n equals 1, 2, 3, and 4. The quantity of n determines the number of sublevels. For example, if n equals 3, then there are 3 sublevels. There are different types of orbitals. You have a spherical orbital, which is S, a dumbbell-shaped orbital, which is P. There's a clover-leaf-shaped orbital, which is D. And then there's an orbital that is so complex in shape that it really isn't defined as a shape. It is represented by F.
How is your model different from Bohr, your expression?
Okay, well, Bohr's model used only one constant number to describe the distribution of electrons, while as I, 4 constant numbers. Another difference is that Bohr considered the electron to be a particle, whereas I consider it to be a wave. And in my model, I'm more focused on probability of the location of an electron, whereas Bohr's model is really on certainty.
That's all we have, folks. I am so sorry, Erwin. Give it up again for the amazing Erwin Schrodinger and his highly commendable atomic model.
You're too kind. Thank you.
Bye. So, we'll see you next time on Breaking Science with me, Hazel Hills.